So good morning everyone and welcome to the another session of structural analysis 2 and I can see most of you are joining fast, so we'll be waiting for another minute and meantime those who have already joined, as usual, please enter your detail in the chat box. I have a couple of important discussions to make with you and then we'll carry on with the further contents, right? So we'll start within 1.5 minutes. Okay, so till then, let's wait for others to join and then we will begin. So don't go anywhere. Stay tuned with this session. It's a good time to collect your writing tools with you so that you can collect your pen, paper, and calculators, get them with you, and based on whatever I work on this, you can also start working. Okay, friends, so I'm back and let's go ahead. So I just wanted to discuss something with you before we progress. We have received a couple of requests from your colleagues and let me say it's from your class at all. Like you still have many doubts as far as our some of the earlier covered contents, specifically on the consistent deformation method. So rest assured that the next session, that is on tomorrow, and then next two sessions, if possible, I'm planning to dedicate to review, to re-explain all the important content to you regarding the consistent deformation method. So rest assured that you are not going to lose anything until you get clear. We will not go ahead as far as the syllabus contents are concerned because we have reached to our, let us say, 60% of the or the 40% of the contents, right? So we are very well tuned with our pace of covering the syllabus, so I'm not worried at all. And even I don't care that if unless you are clear on particular content, there is no meaning of going ahead, right? So I firmly believe on that and I'm happy that you have shared your concerns and I appreciate that. So otherwise it would have today itself I received this. So I think today we'll finish one more numerical on the ongoing discussion on energy principles. Otherwise, we will not be able to fine tune ourselves in this ongoing discussion also. And I'm also very happy to receive your comments regarding that you are comfortable with the fixed beam analysis and the other relevant methods except the consistent deformation. So don't worry about that part. Rest assured, tomorrow I will take you back into the past and will also understand this method completely, just like we are starting afresh, right? So no need to worry about. And I'm sure that you are as clear, as good as you are clear in case of fixed beam in the energy principles also, because I can take it for granted that whatever discussions we have been carrying out in this energy principle chapter is very well easy to understand. It's also we have taken sufficient number of examples with all the varieties nearly, so that you can complete your understanding and practice properly. Right. So I'm sure about this. So let's take one more numerical today, where you will be doing largely all the calculations and you will be giving me the answers also. So one request is to everyone that do not feel shy in sharing your answers. Let it be wrong or right, that is completely different matter. But it will give me an idea that how many of you are actively involved in learning. Because unless you see, there is always a rule that if you want to clear your doubt, you have to create your questions also. And the questions are not only important, but you have to answer to the questions as well. So when I give you some exercise, and now I have explained you the entire method again, that how to solve a particular problem, your duty is to respond to my questions, those I ask during the work that we carry out in the lecture sessions. Because I intentionally ask this kind of questions, because that will clarify your doubt. If you are wrong, you will getting corrected. If you are correct, then you will get a confidence. So there is nothing to lose. That's what my point is when you are answering. So I can notice that only few students which are already decided students, or specific mass of the students are always eager to answer, but most of you are not participating actively. So this is not good for your understanding also, and it is not a complete fruitful outcome of the sessions that we are carrying out since last long time. So friends, it is my overall advice to all of you that whatever we do, because as per my good understanding, I have not rushed in any of the contents, completing the contents, unless you are clear, right? And rest assured that consistent deformation is very much, I would say on the contrary, it's very much easy method to analyze any of the structures. But don't worry, if you are still getting confused, don't get confused. In tomorrow's session, completely I will revise that particular method entirely for the variety of the numericals that earlier we have discussed in lecture number 5, 6, right? So I can give you those data also. I will show you the old slides also, and I will then take you to the re-explanation of the entire concept. But for today, let's complete this as a chapter also, as a variety also, because as far as this energy principle application is concerned, only the frames were pending. And in the last class, if we go back into the last class, this was the latest numerical which we started with, and successfully we have reached to the final stage of drawing the SF and BM diagram and the axial diagram. So I'm sure that you are much more clear on these concepts, and you don't have largely any doubt as far as the solution of this kind of problems are concerned. So I'm sure that you will be able to crack another similar numerical, which is little bit of challenging also, and it consists almost all the varieties. It has unequal spans, it has unequal type of the forces, so it consists most of the varieties. And with the completion of this numerical, we can safely declare that we have covered the energy principle chapter properly, right? But as I said, please be active in interactive sessions. When I ask you to do some work, you have to do it parallel to whatever I am doing in this whiteboard. Okay, so with that commitment, let's begin this today's session. The objective of today's session is to take up one more practice numerical with variety of the load types and the geometry type in the frame. So we are going to analyze the frame with the help of second energy principle proposed by the Castiglione, right? So I have selected this again from your reference book, which you can refer later on for your confirmation also. Let me give you the question first. So we have a frame like this, and 1, 2, and 3. Okay, so this is 1, 2 and 3, that is the height. We have a hinge support here, right? And we have 2 meters height of this column, so it is 1 and 2, right? So I'm trying to develop structural symmetry also. So this is 1 meter. So from the distance 1 meter, we have 1 point load, and let me change it, and we have a UDL here, right, on this member, having an intensity of, let us say, 1 kilonewton per meter, and we have a load, point load of 6 kilonewton here. So then we have 1 meter distance, we have 2 meters distance. This is total height is 2 meter again. If I could wish, I could have changed this data also, like 6, I could have made 5 or 10 or whatever. But I just want to give you this data because later on you can compare and confirm your understanding once you have the solution from your book also. Don't open the books if you have right now. Otherwise, you will lose the charm of doing this, right? So let's do it without referring to the books. A, B, this is a B point. Let's say C and D. There is one more informal point that we can locate here is E. So friends, we want to draw SFD and BMD for the structure using the Castigliano's second energy principle. Right. You know the steps. If you want to rebrush, here it is. The first thing is you have to draw the free body diagram. Second stage is to identify the redundant forces by calculating external SI. Once you locate the redundant quantity, considering that, you have to find the reactions. So here you can see that earlier we selected horizontal reaction as a redundant. Here you can see R, right? So including R, we calculated the vertical reactions as well as the horizontal reactions. And once we had that relationship, then we had started the calculation. Then your main component comes into picture, like you have to identify the segments. And one important discussion we did in this case, that we started with C2B and B2, let us say D, right? Here it is. So then we changed the sequence. Like after that, we went to the AD as a segment and A being the origin. Why we did this change? Because to minimize the length of this central equation of mx, because on a later stage you need to multiply those things with the another value of d del mx upon del r also. So friends, in this case, again, you can clearly see, let me discuss the solution first, right? Drawing a free body diagram is not a challenge. So first of all, let us draw it. Along with me, everyone will draw it in their notes, right? Without any doubt, everyone has to do this. Assume that this is a straight line. Sorry, you have to remove the nature of the support and we will draw the reactions over here. Vertical, that is here. And we will assume that horizontal reaction is also positive because we are not sure, but we can at least name it. Like let's name it as H. This is B at A. So we will give a value to this horizontal component that's like H, right? So HA is actually H. Right? Then here we have another member with us. Please pay attention and focus how we solve the problem completely so that you don't miss out any of the things. Let me draw it straight. Let me try it. Otherwise, we'll carry on. Okay, all right. Manageable, right? So as such, here you have the vertical reaction VD. And again, let us assume that we have reaction HB. We are sure about this value that we have assumed as HA equals to H, because we need to take the partial derivative of all the components with respect to H, because we are going to select H as our redundant additional condition. So if you remove like here, first of all, let me give you the basic concept. Let me draw this point load and UDL on the system, right? So we have drawn the free body diagram as such, and now you can calculate the SI of the system, right? So how many total reactions are there? There are 4, and the conditions of equilibrium are available as 3. So you can have 1. So this is the structural indeterminacy, statical indeterminacy of this structure. And if you remove any of this one reaction or one quantity, your structure will become determinate. For example, if I remove this H for in case here, right? If I remove this H, your structure will have total 3 reactions, 1, 2, and 3. One horizontal, one vertical, and again vertical. So then it will be possible for me to develop all my equations, but that is not the real structure. In real structure, you still have one unwanted or additional quantity that we call redundant. So this redundant we have selected as H, and based on that, we will be taking the partial derivative of all the generalized, let us say, equations for further calculations. Okay. So now let's put the basic equations of equilibrium. So that is step number 2. Use sigma V equals to 0. What it would be? VA plus VB equals to 6. Right. So that is a very simple equation, because this is the 6 kilonewton, and here we have 1 kilonewton of the force. So now another condition that which is very important for us, that is sigma H. That means algebraic sum of all the forces in horizontal direction is 0. So how many horizontal forces we have? One H is here, that is reaction HA. HD itself we have, and we have horizontal force as UDL over here. So let's put them together. So HA plus HD plus, let us say, 1 into 3 total force, right? Because 3 meter is the height, you can see here, equals to 0. We have assumed our distance, I mean the directions of the reactions as per our old understanding, that unless you are confirmed, assume everything as positive, right? So simple HA we will replace with H. We don't know what is HD, so we'll keep it HD as it is, and plus 3 equals to 0. So friends, now we have two values in hand. HD is nothing but -3, -H, right? And we have HA already with us. We have assumed it as H, right? So with this, all the reactions we need to work out. So for that, now you need to work out the V and VB. So carry out the moment of all the forces about any of the supports, either A or B. So let's take moment of forces about point A. Now it's your turn. So please work upon this and come back to me when you are ready with your answer. I want to have answer of VD, right, from your side first. So just give me an answer of VD, and otherwise I will guide you how to do it, but it's very simple. Start taking moment of all the forces about point A. All the forces. So how many forces? Let me confirm with you. One is VD, second is HD, third is 6 kilonewton, and fourth is 1 kilonewton. So you have to at least have 4 equations in your equation. So now you know clockwise, anti-clockwise is that. So please be sure about that, and let's work out VD. First you work out and then I will demonstrate. So I'm giving you 2 minutes for this. And I'm sure that those who have joined have entered that detail in the chat box. So I would like to hear from you. First of all, if you are done, raise your hand. I will unmute yourself. I have opened my participants box and I can see all of you here. So just raise your hand. I will unmute yourself for answer of video. Take your time, like maximum 2 minutes, and then we'll do it on the board. Everybody has to try. So as I said, it's very easy. Start taking moment of all the forces about point A. That's all. So it's basic mechanics of solids, nothing else. Largely, you will see that all these concepts are nothing but based on your old concepts of structural analysis 1 and mechanics of solids. The starting is always crucial, and that's why I don't rush in writing anything on board without your agreement. So I hope step number 1, 2 are clear with you. You know how to treat an example first of all. So first of all, you have to draw the free body diagram that will enable you to identify the redundant force, which is very important. Because after all, you are going to take partial derivative of your equations of moment with respect to that force. So take your time, and 1 more minute I can spare, 1.5 minutes, and I'm waiting for my answer in terms of H. Your answer will be in terms of H, let me tell you, friends. Right? So now I have given you a tip also. So based on that, you can very well work out your VD value. Okay, Albert is with us. Yes, Albert.
2.5 minus h over 3.
All right. Let me register your answer for a while. 2.5. Come again, Albert. Let me unmute you. Yes, Albert. What is the answer?
2.5 minus h over 3.
Minus h by 3. VD. Okay, so let me register this and let's see. Let's take moment of forces. We'll begin from here. Somebody else has raised the hand, I think. Who was there? Please raise again. I can unmute. Henry. Yes, Henry. What's your answer?
1.5 minus 0.33h.
1.5
Yes.
upon h by 3, let's say. All right, so we have two answers varying a bit from each other. Birendra is there. Yes, Birendra. What is your answer? I think I have unmuted yourself. Birendra, come again.
Yes, sir. Sir, I got 5.5 plus 0.6 H.
5.5 plus 0.
0.667 H.
Okay. Well. So we have varieties with us, and let's see how do we go about it. Anyone else? Jeevesh? Yeah, yes, you were there. Jeevesh, you raised your hand. If I'm not wrong, Eric is there. Yes, Eric.
Yes, 1.5 minus 0.67 H.
Okay, that largely 0.67 H. Okay, boss, registered your answer also. Anyone else? Okay, that's good that people are working on the numerical. So that's a good news for us. So let's cross check fatafat and quickly we will go through all this. Like let me take first force, that is UDL, of course. It is here. Let me change the color basically. Okay, let me use red one. So I'm using the first force about this. So that's going to be my height. Total is 3 meters. So 1.5, 1 into 3. That is a total force. It is clockwise. So negative moment. So minus, don't mind, I'm using red color in writing text. Minus 3, or instead of direct 3, let me write minus 1 into 3 into half of 3. So that is my clockwise moment, so negative. So this story is done, over. Now let's reach here. 6 into 1 about this point. So it will create again clockwise. So minus 6, okay, into 1, whether you write or not, that's fine. Now we have these two forces, HD, which is acting at a distance. This is the height distance. This is 2 meter. Complete is 3 meter. So balance is 1 meter. So I doubt that many of you may have made a mistake over here in case. So let's check it. Here we have HD and its distance from reference point is 1 meter, dear friends. Please take care. It is creating moment like this about this point, right? So for that, I will be again taking it negative because it is clockwise, HD into 1, right? And then we have, of course, the VD, the hero of the equation, and it will be creating clockwise positive moment at a distance of 3 meters. So I'll be writing here plus VD into 3 equals to 0. Now, friends, let's go for it. Let's check how we simplify this. So this is minus 4.5. This is minus 6. This is minus H. What is HD? HD is again need to replace with minus 3 minus H into 1 plus VD into 3 equals to 0. So let's simplify this to at least. So it is minus 10.5 plus 3 plus H, because we are releasing this bracket, so it will become positive, plus 3VD equals to 0. So here we get 10.5 minus 3, so it is 7.5, right, plus H, this is going to be negative, plus 3VD equals to 0. So let's write them down in a desired way. This is 7.5 minus H. So this becomes as VD equals to 2.5, because in numerator, sorry, in denominator we have 3, so 2.5 minus H by 3. All right, so that's what is the answer here for us. And let's now go for VA. So now who will give me VA value? Work it out. And you can raise your hand in that case. Yes, Albert.
3.5 plus h over 3.
3.5. Then
Plus h over 3.
plus h by 3. So I think should not be a variation in this answer as such, because ultimately it has to be, I mean, h goes in the 0 and this becomes 6 actually, right? So this looks okay. So let's go with this ahead. And unfortunately, we need to change the page now. And rest of the business is now very straightforward for you. How you make the table. So let me demonstrate it. Again, we'll not hurry up. We'll go stepwise. Don't hurry up, please. Take your time, arrange everything, plan everything properly so that you get your right answers. Assume that this is continuous member, please. Okay. So now here I'm writing it VA. And what was the answer of HA? H is positive. So let's write it. H here. Okay. So here again, we will take 1 meter and 2 meter. Now see, there is an interesting discussion which we require to make here, that here it is HD is again negative, right? So we can do one thing. We can make it like as it is. We'll continue with this as it is. Okay. Otherwise, you can make it negative and take it out of the bracket, and you can make it like this. It's up to you, up to your convenience. So we'll continue with this as it is. So again, let me write here. It will impact on your final answer, nothing else, right? So here it is minus minus 3 minus h. Let's write down minus 3 minus h largely. And here we have one force, that is 6. And here we have other forces like UDL and all. So why not to write the VA value here itself? So that is 3 point, how much? VA is 3.5. 3.5 plus h by 3. And here it is 2.5 minus h by 3. You should avoid, playing with the numerical signs largely, so that you can get your answer in a desirable way. So this height is 3 meter. It is important for us to write down all the segmental heights, because now we are going to write the generalized equation for all the segments. So it is necessary to give names to them. A to B, B to C, C to D again, and this is E. So these are the main points, and now you are all set. Now here I would like to make a discussion, and then after you are free at your end to carry out the calculations. See, in this case, we can see that the frame has 2 columns, and there is a common point which is meeting it at point E. So it is very much obvious that we will not be continuing from any one end and complete it on the other end. So we will not follow the pattern like we start from, let us say, D to C, C to E, E to B, and come to E to A, or B to A, right? But what we will be doing is we'll be dividing this frame in 2 components largely on either sides. Like first we can start from A to B and B to E, and then we will end here. And then again we'll start from D to C and C to E. Because after all, we know that from the first principle that whenever you cut a member at any section, basically it should be in equilibrium. right, on the either sides of the section, right? So should not be a problem for us to understand this concept. And you should also notice that if you keep on continuing with the same sequence from one side only, it will be largely difficult for you to handle that large long equations, right? And it is not suitable for the partial derivative and multiplication and this and that. So in short, follow this always in the frames. Don't create a continuous equation from any one end, but as soon as you reach at the some point in the beam, as far as the as far as the frame is concerned, stop that and stop there, and then take the opposite end as the origin and start developing the equation from other side. So this was the point of discussion I wanted to make. Now here, let's write down our first. Let me help you for the first instance. Member AB. Now we have origin at A, right? We have the length 0 to 3 meters. And let's write down mx. So we cannot, of course, take the moment of VA because it is on the line of action. So from here, let's take a section. Let's stand here somewhere. This is XX. This distance is, let us say, X. Okay. So H into X, of course, that is the first moment, and second moment is due to the UDL. That's all. Right. For this entire member AB. Okay, so let's write them down in a sequence, like this is the force and that is the distance. So it will be anti-clockwise. So positive moment I will be considering. So H into X, that is my first moment, positive because it is anti-clockwise. Now again, the UDL will create another positive moment because this is the length of UDL. You have to consider this is the origin. I mean, this is the point of reference about which you need to take moment. So X is the distance, UDL is 1. So plus 1 into X squared by 2. Is it okay? So that is what is my basic equation for entire segment A to B. I hope you don't have any doubt in this case, and we'll come back later on to this stage del mx upon del h. Don't forget that we have assumed h as redundant. So whatever we have to do it with respect to h only, right? So don't worry about this part. This we can do very easily anytime. But more importantly, I just wanted to explain you how you can carry on with the other values. It is better that I don't draw horizontal lines, otherwise it will look like an inclined line. So anyways, let's continue. Let's go to the another segment associated with joint B. So A to B is done. Now let's go for B to E. So B to E, of course, is the segment, and B is the origin. And needless to add that 0 to 1 meter is the length of that segment. And now let's write down the mx equation. Okay, anyone would like to contribute here? Raise your hand if you want to answer this equation mx for segment BE. Anyone would like to help here? Anyone? No one? Who would like to help me writing the equation for segment BE, being B is the origin. So now I'm running my X from B to E like this, right? And of course, we cannot ignore the other earlier forces. So we have to bring everyone together to reach at point E. So let's take them one by one. Right? So the first thing is first come, first serve. This time we have VA with us, and it will be creating clockwise moment. So what is the VA value? 3.5 plus h by 3. So I will write down first of all 3.5 plus h by 3 into 1. That's it. Sorry, into x. Okay. So that is the first moment of VA. Then again, I will be taking H as a force and full height of this vertical column member, that is 3 meters. And that will be acting as a moment in this portion B to E. So I will write, and it is anti-clockwise. So again, I will write it H into 3. Right. I hope that you are being clear how we take moment. If you are not so confident, then pay attention. Let me tell you once again. First, we have considered VA as a force. So VA, let me draw a separate figure to give clarity. Right. This is our segment B to E. Okay. And our X is moving like this. Okay. This is point E, this is point B, and this is point A. Now I have a force in terms of VA, and this is the distance. So this is a force, that is a distance, so it will create clockwise moment. So I should put negative over here. So it is 3.5 into x. 3.5 plus h by 3 into x. That is my first moment. Now I have one more horizontal force here, that is H, and as such it is not directly applied on member BE, but because of this horizontal force there will be some distance also from the origin. So this distance is 3 meter total given into the problem statement. So H is the force and 3 meters is the perpendicular distance, and it will create anti-clockwise moment in this member. So we'll write H into 3 plus. And lastly, we have the UDL also, right? So how we do it? We need to take total force, its distance, right? And it will be again adding into the clockwise moment on the member BE. So plus UDL value is 1 into total length is 3 into half of the span, that is 1.5. Right. So that is the equation for us. We can come back here on a later stage. So BE is done. Now don't make a mistake of going E to C. Right. Otherwise, this equation you can visualize now. It will be, unnecessarily increased. Right. So let's work from D to C and C to E. So quickly, let me probably I'll not be able to give you the full solution today right now, but at least this important segment of your numerical you can cover up. D to C is the segment, D is the origin, 0 to 2 meter is the length. Don't forget it because it is smaller than the another column. So now how many forces we have, of which we can take a moment when your X is moving in this direction. This is X. So we require perpendicular forces, and this is the only force that we can consider for the perpendicular distance, that is X. So naturally minus 3 minus h into x. So that's going to be our only moment for this segment. So we'll happily write down, easily write down minus 3 minus h into x. And we'll, as usual, we'll come back to this partial derivative later on. Now let's consider C to E. So let's write down C to E. I'm sure that I'm not rushing in, and you are getting it clearly that how to write these equations. This length is also 0 to 2 meter. Be careful because total length is 3 meter and this is 2 meter, right? This 6 kilonewton is an eccentric load, right? So 0 to 2 meter is there. Now let's check how many forces are there for us to take moment. First force is, of course, the vertical reaction, and second is the horizontal reaction. Both will contribute to the moments. Let us see now. You have to move your X like this. See, movement is very important because you are targeting the origin like this. So X is moving here. So somewhere you are here, right? So you have to take moment of both these forces about this point. So we'll be using VD into X. So VD will be creating anti-clockwise positive moment. So I'll write down VD into into X. That's all. And here with the full length, full height, -3 minus H into 2, right? That will be creating again the anti-clockwise moment for this member. So I will be taking it again as a positive moment, -3 minus H into 2 meter, because full length now you have to use. So I think that's all, and then you can go for partial derivative. So friends, I have given you all the important equations over here. Here you can replace VD again. So that is nothing but 2.5 minus H by 3. So let me write it down here itself so that you can simplify your equation effectively. So it is 2.5 minus H by 3. Okay, friends. So into X. So now I think you are done with your whatever required this things values. So let's come back to del mx upon del h. So here it is X because we have only one term which consists H. Here you need to simplify and expand this this term, like 3.5 into X plus H by 3 into X, right? So basically it is minus X by 3 first of all, minus X by 3. Then you have plus 3, right? So that is what is the H value, because we have H at 2 places, right? I hope you got the point how this has come negative, because we expand this term and it will create negative. Then again you have to expand this. This is minus 3x minus hx. So minus x will be del mx upon del h for this equation. And here finally, again you have let's say minus x by 3, because you take h derivative, and here it will be minus 2. Here you have to expand this 3 into 2 and 2 into h. And it is negative, here it is plus, so it will be negative again. So like this, friends, we have done all this necessary things. Now you know what you have to do. Yes, you just need to sum them up and put them into the form of the equation, our final equation in terms of del u upon del h equals to 0. So that will give you 0 is equal to 1 upon ei integration according to the lengths. So first length is 0 to 3. Put the equation mx del mx upon del h dx plus second segment ei 0 to 1 meter, then mx del mx upon del h dx plus 1 upon ei. Second segment is 0 to 2 meters. From the other side, it is again mx into del mx upon del h dx, and finally you can write your final expression here somewhere, anywhere, plus 1 upon ei 0 to 2 meters mx del mx upon del h dx. So friends, I think you can crack this, because now it's a game of expansion and multiplication. But be careful about the signages, because that will impact a lot on your final equation and answers. So I'm trying to write here. I'm not sure whether we'll be able to accommodate the entire solution or not, but let me try it. 1 upon ei, still we have some time. So 0 to 3, this mx, you can do in your own notes, hx plus x square by 2. So that we can write here hx plus x square by 2 into what is that? X. Okay. Into x dx, right? So first thing is written. Now let's go for it. Ideally, we'll take 1 upon ei constant out of this entire term. So we can write it here like this. Okay, so I have taken this out of the entire equation. You are better in mathematics than me, so I'm sure about that you know what we are doing. Ei, 1 upon ei, right? Okay, so that we can avoid unnecessary writings over here. 0 to 3, then 0 to 1 meter. Let's say what is the equation? It's going to be little bit of lengthy equation. Minus 3.5 into h by 3 into x first of all. So minus 3.5 plus or minus 3.5 plus h by 3. So plus h by 3 into x then plus 3h, so plus 3h and finally we have 4.5. We can multiply this on the spot and we can write it plus 4.5 into, don't forget that now you have to multiply it with del mx upon del h, and that is x by 3 plus 3, x by 3 is negative. So we'll keep them as it is, x by 3 plus 3. Now your multiplication has been completed. So this is dx. So this is the crucial part of this numerical. When you are expanding everything, be careful. First you expand internal terms and then you multiply with the external terms. Okay. So plus 0 to 2 meters, friends. What is the equation? Minus 3 minus hx. So this is minus 3 minus h into x, and that is again to be multiplied with del mx upon, that is minus x. So it's a simple and obedient equation and plus let's go for, sorry, it has been taken out, so there is no need to write it again. Simply 0 to 2 meters. So let's write down the final expression. 2.5 times. Again, it's going to be a little challenging for you. 2.5 minus h by 3. 2.5 minus h by 3 into, what was that? Into x, of course. So it is x plus minus 3 minus h into 2. So plus, I will avoid this for a moment. Plus minus 3 minus h into 2. Now I can put them into the bracket largely and multiply with minus x by 3 minus 2. Minus x by 3 minus 2 into dx. So friends, as you can see, it's a lengthy calculation now for you, but I'm pausing here and you need to carry out from this point and bring me the final answers, and let me share the answers with you. Also, let me give you actually at least one answer, that is h, and that is 1.36 kilonewton. Make a note of this answer. The answer of h, which is unknown, because now you have to get the value of h out of this, because that is the hero of our equation. So the right answer for h is 1.36 kilonewton. And once you have that with you, I think you will be able to solve vertical forces also. And based on that, you can take moments also, and you will be able to draw the SFD BMD. I understand it's not that easy, but again, since you want a revision of the consistent deformation method, so whatever, I'm ready. If you wish, tomorrow class we can complete this numerical, or tomorrow we can go for consistent deformation revision also. I will be open for both the conditions, whatever your suggestions, but I think largely you require a revision of the consistent deformation method. So I will begin with that definitely, and if necessary, we'll go for the another week also for the consistent deformation method revision. And before your test, you will become very sound and safe for using of this method in the examination. And as such, this energy principle is concerned, there is no difficulty, I think, apart from drawing the free body diagram, drawing the SFBM diagram. But excluding that part, I think you are out and out clear about how to handle these complex type of the loading. You can see that how you can realize that how complex it is, but now you are able to solve it, right? So the only small care should be taken that when you are working on the initial steps, you should be very clear about the reactions that you have calculated. Otherwise, this is completely fine. I'm sure, more than sure, that you have understood all this, how the equations have been made and how we have kept the h in each and every equation, so that later on we can take their partial derivative. And now the ball is in your court, so you have to find out the h value out of this, and I'm giving you the answer also for practice. Just try it, try to understand, try to identify, right? And we will get discussed with, we'll be discussing the consistent deformation method in tomorrow class, right? For your, on your demand. Okay. So we'll meet tomorrow. Don't worry about anything. Everything will be fine. Stay safe, take care, and carry on with your next session. So thank you all for joining this session. We'll meet tomorrow together. Thank you all.